Hi, this is Tom Reardon, math teacher from Ohio. Here we're going to look at a Pythagorean activity called What's Right About Triangles. So I'm going to click on page 1.2. We're going to go ahead and generate a random set of squares, and we're going to grab and drag closed circles to try to form a triangle using one side of each square. And we want to know what type of triangle is formed. Is it acute, is it right, or is it obtuse? Or if there's no triangle possible, why is there no possible triangle? So we'll go to page 1.3. And so the side lengths are 9, 12, and 15. See the color coding there. The area of the squares are 81, 144, and 225. And so I'm going to grab this black point here and pull it and try to make these meet. I got to kind of pull around a little bit. Oh, and there we go. A little bit of finagling, but 90 degrees. So a triangle that has 9, 12, 15 makes up a right triangle. To get another one, I'm going to click on the down arrow here, and I have 3 for green, 5 for blue, 6 for red. And let's see what kind of triangle this makes. If I pull this down, ooh, it's a 94-degree angle, not a right triangle, it's an obtuse triangle. So 3, 5, 6, those side lengths make up an obtuse triangle. And I can continue to do this. Generate another. Here's a 6, 8, 10. So I'll go ahead and grab these points, and when I pull them together, bingo, another right triangle. 6, 8, 10 form a right triangle, make up a right triangle. Try another one, 4, 6, and 10. And so I'll try to pull those together. And it says here that it makes a 180-degree angle, and that's because 4 and 6 add up to 10, so there's really no triangle possible there. 4, 4, and 7. Pull these, see if we can get what kind of triangle is this going to be. Obtuse triangle, and so on. So we can continue to do this. Now this we already know. This is an equilateral triangle, so I don't even have to do that one. Though I guess I could, just to show it. Yep, there's the 60 degrees there. And 6, 8, 10. I'm sure we did that one before, but let's pull it down here and see. Yep, right triangle. So on page 1.4, it says the next page is a proof of the Pythagorean theorem visualized. When we say notice how each square becomes a parallelogram with the same area as a square. Okay, so we'll go to page 1.5. And we have this area, this square, and this area, this square right here. This would make up the right angle, right? The blue and the green, and the red would be on the hypotenuse. So it says grab this and drag me down. So let me do that slowly and see what's going on there. So those are becoming parallelograms, the same area. Pull them down there and bingo, they make up the same area as that square there. Well, that's kind of cool. And if that's true no matter what if I make a bigger square here? If I move this over here like that, make the blue bigger, can I still get that same idea? Yeah, I can. Again, I can make this square smaller and try the same thing and even move this point, let's say over here, almost in the middle. Okay. So this is a kind of a visual proof of the Pythagorean theorem. Next page, 1.6, it shows how a parallelogram and a square can have the same area. And let's go on to that last page. And it shows me a square that has a perimeter of 24 units, but an area of 36 square units. And I'm going to grab this white point, and as I do this, I'm starting to get a parallelogram type look. And notice that the perimeter keeps changing, but the area is still 36. And why is that? Why is the area still 36? And that dark blue and light blue have exactly the same area. And why is that? Now, before I answer, let's switch this to vertical. Same idea again, grab and pull. Again, same area, different perimeter. And why is that? Well, the reason is, let's go ahead and look at this one. Notice the base for the dark blue is 6 units, and the height for the dark blue is 6 units. But for the light blue, it's also 6 by 6. So remember, area of a parallelogram is base times height, area of a square, base times height. So that's why that worked before when we did this. Okay, when we showed this, these squares we had the same area as these parallelograms that we got, and we pull and dump them down in there. So there's a lot of geometry, a lot of math going on here, a lot of visualization, and we hope you enjoyed it. If you want some information about it, if you want some information about this, there's a website where you can get the TI-Nspire file for it, a link to the software to try for free for 90 to 180 days, and also the link to this video. Enjoy.